Hello everyone, welcome to this video. In this video, we are going to solve question from December 2011 consisting of 4.75 marks. The question is, consider the functional I of y which is given to be integration from 1 by 2 to x1 square root of 1 plus y dash square dx subject to the condition that the left end of the extremal is fixed at the point 1 by 2 and 1 by 4, that is the left end point is given to be fixed and the right end point x1 y1 is movable along the straight line y is equal to x minus 5. So this is given to us. Moreover, they are saying if c1 and c2 are the arbitrary constants involved in the functional, then which of the following is true? Then they are asking whether the general solution of the Euler equation satisfies this relation, the transversality condition that holds at the right and yields this condition, the relation this is true, right, or the extremal is this, right? So among these four we need to suggest which of the following is correct. So let us get started in solving the question. So first of all, let us solve the Euler-Lagrange equation. F of y minus d dx of fy dash is equal to 0. What is f in this question? It is given to be 1 plus y dash square. So what would be f of y? It would be 0, and f of y dash, this would be y dash divided by square root of 1 plus y dash square. So let's plug in these values. So we have minus d dx of y dash divided by 1 plus y dash square root is equal to 0. So this gives us y dash upon 1 plus y dash square root is equal to some constant c1. Let's call it c1 because in question it is given c1, right? So solving this, you get y is equal to c1x plus c2. We have solved this many times, right? So this is the equation of straight line. So now let us substitute the left end condition, left boundary condition. What is that? We are given that x is equal to 1 by 2 and y is equal to 1 by 4 at this point. So let's put these values in this equation. So we have 1 by 4 is equal to c1 by 2 plus c2, or I can write this as 1 is equal to 2c1 plus 4c2, right? So this is the relation that I obtain. Let me mark this as this equation as 1, this equation as 2. So here if you see the options, you will see that option A has been attained. So option A is correct. So let's look up for another options because it is a multi correct option, right? So what is the situation in this case? They're saying you have coordinate axis and you have a point somewhere here 1 by 2 and 1 by 4, right? This point is 1 by 2, this point is 1 by 4, and you have another point which lies on this line, y is equal to x minus 5. So if I substitute x as 0, so y is minus 5. So I have 2 points, this minus 5 and 0 and minus 5, right? And this point as 5 and 0. So this line passes through these 2 points. So in this case, our extremal is something of this sort. That shortest line which is having the least distance from this point. So in our case, let us call this, right? So now what we need to do, this point is x1 y1, right? So obviously this point x1 comma y1 lie on equation number 1. So we get y is equal to c1 x1 plus c2. y1 is equal to c1 x1 plus c2. So this is equation number 3. Moreover, this point lie on this line. What is the equation of this line? It is y is equal to x minus 5. So we have y1 is equal to x1 minus 5. So this is equation number 4. From 3 and 4 I have c1 x1 plus c2 is equal to x1 minus 5, right? So let me call this as equation number 5. From equation 2, from here I can take the value of c2, right? So c2 is equal to 1 by 4 minus c1 by 2. Let me put this value onto equation number 5. So I have c1 x1 plus 1 by 4 minus c1 by 2 is equal to x1 minus 5, right? So I wanted to calculate c1. So c1 x1, so I can take c1 common, x1 minus 1 by 2 is equal to x1 minus 5 minus 1 by 4. So let's call this equation number 6. So now at right boundary, I have to apply transversality equation, right? What is that? Transversality condition. If you have one endpoint moving, in that case you can apply the transversality condition. Let's call this straight line as psi of x. In that case we obtain psi of x is equal to x minus 5 such that psi dash becomes 1. Derivative of this psi with respect to x, so that becomes 1. The transversality condition is that we have f plus psi dash minus y dash fy dash is equal to 0 at the point x2, right? So let us have a look at our f. What is our f? F is given to be square root of 1 plus y dash square. Moreover, this is y, right? So what is y dash? It is c1. So we'll use these values in this equation. So f is square root of 1 plus y dash square plus psi dash, as you have seen, psi dash is 1 minus y dash is c1 into fy dash, the derivative of this quantity, that would be y dash divided by square root of 1 plus y dash square at the point x2 is equal to 0. So here also I can put the value of y dash as c1. So I have 1 plus c1 square plus c1 minus c1 square is equal to 0. What I did, I took the LCM and moved this term to the right hand side. So this gives me c1 and c1 square and c1 square cancels. 1 plus c1 is equal to 0. So this gives me c1 is equal to minus 1. If c1 is minus 1, let us calculate other quantities. Let me substitute this value of c1 into this equation. So what I'll be getting, I have c1, no, not c1, I have the value of c1. c1 is minus 1, right? So I have minus of x1 plus 1 by 4 plus 1 by 2 is equal to x1 minus 5. Yeah. So I can move this value over here. So let us solve this. So this is 3 by 4 plus 5 is equal to 2x1. So this gives me 23 by 4, or 23 by 8 is equal to x1. So this is x1. What is y? Let us calculate that also. So if I substitute this value in this, so I'll get y1 is equal to 23 by 8 minus 5, right? Moreover, c1 is equal to minus 1. So let us calculate the other constant c2. c2 would be 1 by 4 plus 1 by 2, that would be 3 by 4. So our extremal at the end becomes y is equal to, it was c1x plus c2, right? C1 is -1, C2 is 3 by 4. So this is the extremal. Let us look at our options. Yeah, so this is also one of the option. So this is also correct option, right? Moreover, the transversality conditions gives us this. Is this true? Let us look at our calculations. We have solved the transversality conditions here as y dash was c1. So we would have obtained 1 plus c1 square root plus 1 minus c1 divided by 1 plus c1 square root is equal to 0, right? So this condition is also true. So B is also correct option. Now let us look at this condition. Yes, we have also obtained this relation during the calculations here. So this is also the correct option. So here all the given options are correct. So I hope you have understood the problem well. Thank you for watching the video. I'll see you in the next one.